So question 1, you're first asked to explain why this is an example of a function. So it might be actually useful to do these 3 questions first. So the input variable here, that's what we're looking for, would be the number of cups purchased, say, because we're told that they have $20, they buy C cups of coffee, but most importantly, we're told that the amount of money that is left depends on the number of cups that he buys. So in general, we'll say that the dependent variable depends on the independent. So if it's phrased in this way, that would be the input, or the input variable, or the independent and dependent. Those are synonymous names. So this would mean that the input is the number of cups purchased or bought, and then the output variable, or the dependent variable, would be the amount of money left. Because the amount of money depends on the number of cups he buys, so it is a dependent variable. Next, we're asked to write an equation expressing the amount of money, D, that they have left after purchasing C cups of coffee. So this is in terms of C. So this would be D, and this would be C. And therefore, the amount of money would be D. This equals, they have $20. So they're going to start with 20. If they didn't buy anything, they would still have 20 left. And then we're going to subtract. For every cup, right, 1 cup is $1.25. So if they buy 1 cup, they lose $1.25. If they buy 2, they would lose $2.50, and so on. So it's 1.25 times C. So we'll write this as 1.25 times C. So if you're wondering where this came from, again, this is the initial amount, and this is the amount lost per cup purchased. And obviously you would subtract, because they're not gonna accumulate money for buying coffee, they would lose it. Okay, and then the domain. So the domain is a set of all valid input numbers, or all numbers that can be allowed into the function as an input value. And because the domain here for the input variable is the number of cups purchased, so it would be, well, you have to buy at least one, or you have to buy an integer amount of coffee, right? You can't buy half of the cup. So it would be all integers from, right? So you can buy 0 cups of coffee. You can't buy a negative cup. So from 0 to, now what is the maximum amount that you could buy? Well, it's not infinite, because you only have $20, right? So we could say that if you spent all your money, right? So if D is 0, so you spend everything, then D is 0, which would mean that 20 minus 1.25 C is 0. So we're going to solve for C. You'd add this to both sides, and then divide. So 20 divided by 1.25 is C, and that value is 16. So the answer here would be from 0 to 16. Because again, and you can verify this if you want, if you buy 16 cups of coffee, you will not have any money left, so you couldn't buy any more than 16. So your domain would be all integers from 0 to 16. So 0, 1, 2, 3, 4, 5, etc. The range, so remember that so your domain is the set or the collection of all valid input numbers, and out of room, the range is the output value. So it's not the variable, it's just the numerical values that it could be. Is it positive? Is it negative? Is it an integer? Is it a decimal? What is it? So here, well, the range, the output variable is the amount of money left. So that could be, you could have anywhere from $0 left if you spent everything, and you could have up to $20 left. So that would be your output. So your range, the set of those values would be numbers from 0 to 20 in increments of 1.25, because you will not have a value of money left in between two cups, two different amounts, right? Like your value will, they will be spaced out by the amount that you can purchase at one time, which would be $1.25. Okay, so there's a lot in this problem, but that should be the solution for this. The next one I want to look at is question 5. So here you're given 3 functions and asked to find some following information. So f of 0, you would evaluate, remember this means that you evaluate f at x equals 0. So f of 0 would mean that you put 0 into every x value that you see. So 0 squared plus 3 times 0 is just 0 plus 0. So your answer would be 0. Not too bad. G of -4 is the same thing. You evaluate the function g at x equals -4. And it's x because that's the input variable. This should be something else, as we'll see soon. And so g of -4 would be the square root of -4 squared minus 2. Now, -4 squared is 16. So 16 minus 2. And that's the square root of 14. P of -2, again, you would evaluate p at -2. So and here the input variable is t, so I'm going to say at t equals -1/2, not x. So this is 10 minus 3, -1/2 minus 1. Or 10, you can distribute the -3 to each, remembering that you have a negative. So this would become plus 3 times 1/2. Remember, because if you have a two negatives, it becomes a positive. And then the same thing, 3 times 1. So you have 10 plus 3 over 2 plus 3. Oops, I'm sorry, this should be plus 1. So this would be minus 3, not plus. Minus 3. And that would give you 8.5. It might be easier to first write this as 10 minus 3 times, so negative 1/2 plus 1 is 1/2. So this would be a little bit shorter. Maybe you want to, instead of distributing, you want to do it like this. It's up to you, both would work. So you have 10 minus 3 over 2, and that's 10 minus 1.5 or 8.5. You get the same answer, but depends how you want to think about it. Okay, so g of 2t, your input variable just is replaced with 2t. So this would mean that you would take the square root of 2t all squared minus 2. And when you square something in parentheses, you have to square each term. So this is 2 squared times t squared minus 2, or the square root of 4t minus 2 squared, 4t squared. P of x plus h. So again, same procedure. Replace the input variable here, that's t, with x plus h, because that's what we're evaluating the function at. So p of x plus h is 10 minus 3 times x plus h plus 1. Right? You replace t with the quantity x plus h. Now you have to distribute this. So this would be 10 minus 3x minus 3h minus 3 by putting the negative 3, multiplying that to every term inside the parentheses. And so you would have 7 minus 3h, or 3x, minus 3h, because 10 minus 3 gives you the 7 there. And finally, for part F, I'd recommend that you do this in pieces. So whenever you have to, so here we're evaluating the function twice, and my recommendation is that whenever you do that, you do each one separately. So f of 3 plus h would be 3 plus h squared plus 3 times 3 plus h. So again, you replace the x in the formula for f of x at the top with 3 plus h. And you need to remember here that when you square this term, you're actually multiplying the two terms together. And so this would be foiling when you distribute this out. So this would be 9. And then you'd have 3h plus 3h plus h squared. So in order to do this, we do 3 times the 3 gives you the 9. 3 times 3h, 3h. H times 3, 3h, right? And then h times h is h squared. And then for the second term here, I'm going to do this now, so that would be 9 plus 3h. And there's a bunch of stuff here that will simplify. So you'll end up with 9 plus 9 is 18. So maybe we'll do the h squared first. So h squared, you have 3h, 3h, and 3h. That's 9. And then plus 18. Now, that's not the whole answer, right? We need to do f of 3 and then subtract these results. So f of 3, you evaluate the function at 3, you get 3 squared plus 3 times 3. That's 9 plus 9, which is 18. And so finally, when we subtract these two things that we found, so this first piece is h squared plus 9h plus 18. The second one we got 18, so we'll subtract, and you end up with h squared plus 9h. So that would be your final answer. So again, I recommend that you do this in steps, and then you take the difference.